all. Welcome to Chapter 9 in our first lesson. We're going to move into radical expressions, perfect squares, kind of stuff we've done before and discussed, but we're going to go in more deeply. So we're going to start doing this lesson over 2 days. So this first lesson is going to simply be with numbers, and then our next lesson will be with variables included. So this is pages 226 to 227 in your textbook, so you can go ahead and write that down. Feel free to fill in today's date as you're taking notes. And then let's get started on some of the terminology for this lesson. All right, so the first thing we're going to see, and we should know this when we take a square root, is that symbol. If you didn't know what it was called, it's called a radical symbol. So you might have like a radical with a number under it, and I think you should know this one. The square root of 4 is 2. Or if we get a little bigger, the square root of 225. Ooh, do you know it? 15. And some things, like the square root of 8, are not perfect squares. What we would say is they do not come out evenly. There is a way to simplify that, though, so hang on tight, and we're going to find out what it is, okay? All right, the next one's called a radicand, and the radicand is simply whatever's written underneath the square root symbol. So the radicand in this example here is x minus 4. I know it's hard to see, but there's a square root of 5 in there. Or the radicand, if we stick with 225 here, is, I'll change my pen color, underneath. That's the radicand. It might look like 224x squared y, and then that does mean that everything under there is again my radicand. So everything underneath is the radicand. The symbol that it's written above it is called the radical, and the whole thing is called a radical expression or a square root expression. So we're just going to draw some arrows here. All of these things we wrote already are radical expressions, an expression that contains a radical sign. Well, that's that thing up there. And it's the whole thing, though. Or it is a square root expression if we draw an arrow, and a square root expression is an expression that contains a radical sign. So the same terminology, both the same thing. And then the last thing says, and we'll talk more about this later, but I'll show it to you now, the product property of square roots. So if you can break down your square root into a multiplication problem, so let's finish these signs. I know they're not on there perfect. So if I have the square root of AB, that's the square root of A times the square root of B. It's the same thing. So for example, if I have the square root of 27, I can break that down into the square root of 9 times the square root of 3. And actually, let's do a little hint. The square root of 9 is a perfect square. If I take the square root of 9, that is the number 3. So 9 turns into 3. The square root of 3 here does not have any perfect squares in it. So my final answer actually is 3 times the square root of 3. If you didn't follow me, that's okay. We're going to do that right now. All right, so flip the page over and let's do a few examples. The directions today will just be with numbers, but it's going to express each in simplest radical form. So you're going to have to do some perfect squaring in your head. Let's do a little list down the side for the first time. If I have 1 squared, that's 1. If I have 2 squared, that's 4. 3 is 9. 4 squared is 16. 5, 25, 6. Squared, 36, and on and on and on. Those numbers are going to be so important because if I have the square root of 1, it's 1. If I have the square root of 4, it is 2. These work backwards. If I have the square root of 9, it is 3. If I have the square root of 16, it is 4. Square root of 25 is 5. And the square root of 36 is 6, and on and on and on. You're going to want to either have a list out or get really comfortable with those numbers. So remember, the number times itself is a perfect square. All right, so now let's think about the number 400. We want to simplify this down as far as we possibly can. Is any number times itself 400? Well, the answer is actually yes. 400 is a perfect square. So 20 times 20 is 400. That's our math problem, okay? So the square root of 400 simply is the number 20 with nothing left behind it in a radical symbol because 400 is a perfect square. If I cut that list going all the way to 400, we would have found it is 20 squared. So my final answer for this one is 20. Number 2, the square root of 30. Now what I want to do is figure out a multiplication problem that has any perfect squares in it. So I'm going to jot a little work down on the side. I'm going to write all my multiplication problems that give me 30 and 6 and 5. 5 times 6. Now, look at this list. Are there any numbers that are perfect squares in there? Our perfect squares were 1, 4, 9. This is 1 squared, 2 squared, 3 squared, 4 squared, 16. 25 is 5 squared, 36, 49. 8 squared is 64, 9 squared is 81. Are any of those numbers here in this list? And the answer is no. We were looking for perfect squares. Well, since we didn't find any, there's nothing to pull out of the square root of 30. The square root of 30 is already in simplest radical form. I can't pull any perfect squares out of it. Since I can't pull any out, that is actually my final answer. All right, now let's put what we just did into practice with one that we can pull something out of. The square root of 75. All right, let's think about some multiplication problems of 75. I'll write a couple extra down on the side so that you have some notes. So 1 and 75, 2 does not go in. Does 3 go in? It does. It's 3 and 25. And then 5 would go in. 75 and 5 is 15. All right, now look at that list and see if you see any perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 25, let's just keep going, 36, 25, and 25. This is the problem I'm going to use because there's a perfect square there. I'm going to rewrite this as that multiplication problem. All right. So any number that is a perfect square, I want to actually take the square root of. So the square root of 25 is 5. This 5 is going to move onto the outside of the house because I am taking the square root of it right now. And so it's going to move outside the radical symbol. Now don't be deceived by the fact that there is a negative sign there. That's fine. I'm just going to write -5. That got rid of the 25 because I took the square root of it and got it outside of the radical symbol. But 3 is not a perfect square, so that has to stay inside the radical symbol. My final answer is -5 square root of 3. That is simplest radical form. I can no longer simplify any perfect squares out of anything inside the radical symbol. All right, number 4, 160. So if we think of the number 160, I know that 2 perfect squares actually go into this, and I want to choose the biggest one. So let me write a couple down. 1, oops, not 2, don't write that. 1, 2 squared is 4, 9, 16, 25, 36. I will tell you that I know that either 4 goes into it or 16. Now, if you use 4 to begin with, you would have to simplify it farther, but if you can figure out what the biggest perfect square that goes into it is, then you'll have it simplified all the way down in the first place. And this one's a little different because it has a 3 on the outside of it, and once we start to pull stuff out, we'll talk about what that means. So, I'm going to use 16 and rewrite this problem as a multiplication problem, and it's 16 times 10. Now, I know I did it right because 10 doesn't have any perfect squares in it, so I picked the biggest one. All right, now we need to take the square root of 16 to get it outside of the house, which is 4. I took the square root of it to move it out here, so it is no longer inside the radical symbol. So what do you do then with this 3 and this 4? Do you add them or subtract them? Well, in fact, you multiply them. So I'm going to write an extra step here because you don't really need to have all this. It's 3 times 4 times the square root of 10, and I would simplify that down to say 12 square root of 10. All right, so 3 square root of 160 turns into 12 square root of 110. And I wasn't clear before, but I should, between this 3 and this 160, or anytime you have a number outside, you are multiplying here, okay? All right, last problem. This is an extra from me. 5 square root of 92. 5 square root of 92. We need to go ahead and figure out what perfect squares are in here. So off the top of my head, this is a harder one. So 1, and we never use 1, but 1, 4, 9, 16, 25. What I'm going to do is just grab my calculator and start dividing. So I'm going to take 92 divided by 4 on my calculator to see what I get. And in fact, I actually got, oops, let's not write that. Let's do 23 times 4 is actually 92. And I can see that this 23 isn't going to have any more of these perfect squares in it. And so I'm going to use 4. So I'm going to rewrite my problem. 5 square root of 23 times 4. I'm going to take the square root of 4 to get it out of there, and that's going to be 2, and that gets rid of it. The 2 comes to the outside, and I multiply those together. So my final answer is 10 times the square root of what I have left, which is 23. I've got no more perfect squares under my radical expression, and I have now finished this problem. It is in simplest radical form. Good luck with the homework, everybody. Let me know if you need any help, and hopefully I talk to you soon. Have a great day, everyone.